can start recording. So maybe I can just call it problem solving. Am I audible? Yes. Yeah. Problem solving. No. Yeah. Okay. So so maybe we can do say mixture of this just integration, differential equations, and even a bit more. So in fact, let us begin with a kind of a lemma which we had last time, right? So last time there was a lemma which gave us a condition when the limit for something x going to infinity will exist. Yeah? So this was the thing. So we said that limit of a function x going to infinity exists. This is what basically we wanted to prove, and if and only if one direction. But so can anybody recall? I think Raghav was not there, so maybe Rasavro, if you remember, or kind of. So there was an interesting criteria which we said will imply existence of limit when x goes to infinity, and we'll try to see if that is correct. So yeah, so you know it, but maybe you don't know what I'm asking. So there was this criteria, right? The criteria was given epsilon greater than 0, there exists k which depends on epsilon such that, and this is a very useful lemma, I think. And also it's not something something very surprising, right? Because it's just similar to the Cauchy criteria. But let's see, such that fx, yeah, it's okay, fx minus fy mod is less than epsilon for any x and y bigger than k epsilon. Right? So first, someone tried to prove this the easy direction. Yeah. If the statement is clear. So limit as x goes to infinity, and this is actually connected with asymptotes. This is basically, I mean, the limit you get if the limit is a linear function, and that is one kind of asymptote. It's a linear, that's a linear asymptote. Or no, I mean, it's a horizontal asymptote. Well, okay, never mind. There's something more, but yeah. So x doesn't change much when it goes to infinity and goes to some fixed place. So how could you use that to prove the easy direction? Go on, this, yeah. This is just like if a sequence has a limit, then this criteria is satisfied, right? For any epsilon, there is a n epsilon such that for all mn bigger than that n epsilon, the differences. That should be easy. I guess it's a review of limits and all. Huh. But we want to show that that will not happen. Yeah. So I can understand what you're saying, but if k epsilon is also large enough, right, then that will not happen. So if k epsilon is equal to large enough, so if you pick a large enough k epsilon, then beyond that, f is in an epsilon band, right? You can say that epsilon band is around 0, for example, right? For example, right? So beyond k epsilon, f is inside this epsilon band. Then won't this imply that any x and y, the difference will be less than epsilon or less than 2 epsilon. Sorry. Right? So intuitively, it's okay. So intuitively, there's no contradiction. Now try to just give a proof. Raghav, do you see this? This is because suddenly we are kind of doing limits, but this is what improper integrals are. Okay, so intuitively it's okay, right? That the entire thing has to be, now I've just drawn the epsilon band around 0, it could be around any point, but and is inside the epsilon band after some point. So difference between any 2 points cannot be more than 2 times. That's the basic. So just prove it, just say it as a proof, but you have to, someone has to say it as a proof. Otherwise, yeah. Drink some water. Yeah, so you can just say that let the limit be L. Right, and in fact, let me say that this is less than epsilon for all x bigger than. So let me just say some delta. Let me know, or maybe delta of epsilon. Okay, no, so actually this is not good notation. Let's just keep it k. Right, and so for all x and so for also y, that's all. So you're right. I mean, it's just basic. For all y bigger than k epsilon. And then you just add these two inequalities. So you can get that fx and xy cannot be more than, or you can add and you can, yeah, apply triangle inequality. So this direction is easy. This direction does not need anything. It doesn't even need the fact that we are in reals. If you're only in rationals, still it will work. If you're in integers, also it will work. This is just a basic set theory. It's a set theoretic. But we want to try to prove the other direction, and that is awesome because that kind of thing is very useful in the more interesting questions, because then if the limit is such that it's extremely non-constructive, if you cannot find the limit at all, if it's that kind of limit, you cannot describe it at all, then this can help you to still prove that limit exists. Yeah. So let's now try to show the other direction. This is, you can call it Cauchy criteria for existence of limit, but usually